Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
Susmita?
Yeah, yes, sir. Good evening. You can start the session, sir.
Yeah, fine. Good evening, guys. Can you please reply? Guys, all the people. What about the remaining people? Are they joining slowly? Fine. Tarun, give the reply. Tarun. Guys, all many people, please give the reply. Tarun, let me complete the this one. Which one? Like a binary search tree. After completing the recursion, then I will go for the hacker rank question. So only 3 days we have. In the 3 days, one day I will cover the hacker rank question. One day I will cover the time complexity and space complexity. And one more day I will cover the dynamic programming. Okay, now 3 days I will cover the 3 topics. No need to worry. Fine. Let me explain the recursion. So, what is a recursion? A function calling itself. A function calling itself called as the recursion function. Can I explain again? What is a recursion? A function calling itself. A function calling itself called as the recursion function. Recursion. We will use recursion in binary search tree implementation. We will use recursion in where? Binary search tree implementation. Take the 2 points again. Take the 2 points. A function calling itself. A function calling itself. Guys, whoever are taking the notes, you can take the notes. A function calling itself. A function calling itself called as recursion function. Called as recursion. I'm providing the notes also. Whoever are taking, you can take it. Point number 2. We will use recursion. We will use recursion while implementing the binary search tree. We will use recursion. We will use recursion while implementing the binary search tree. Binary search tree. We will use recursion while implementing the binary search tree. Binary search tree. Fine. Now, can I explain recursion through one example? I will explain recursion through one example. Online people, be active, guys. It's very, very important for the academic students. Who are appearing for the BTech exams. Who are appearing for the BTech exams, it's very, very important. Yeah. How to create one core Java program? Answer: class test. Class test. Fine. And another thing, how to create a main method? Answer: public static void main. Main. Answer: main string array args. Inside this one, call one method. Inside this one, we should call one method. Which method? Recursive method. Call one method. Which method I'm calling? Recursive method. And close this one. How to create a recursive method? Answer: how to create a recursive method? Can anyone tell? Static. Reply: static void. Which method? Recursive method. Recursive method. Inside this one. Go to the SOP statement. System dot out dot println system.out.println of, we should pass the start and call the recursive method again. I wanted to call the recursive method again. How to call? Recursive method and go to the end. How to work with the end? How to display the end? System dot out dot println end. Guys, all the academic students, I'm recommended you please note down this one because this is one of the academic level questions. And close the test class. Close the which one? Close the test class. Guys, execution starts from answer. Execution starts from main method. Coming to the execution starts from the main method. Am I right or not? So, which method I am calling? Which method I am calling? Recursive method. I'm calling the recursive method. Whenever we call the recursive method, automatically interpreter comes here or not? Interpreter will comes here. Interpreter will reach us here. And whenever interpreter reaches here, automatically memory will be allocated in the internally or not? Memory will be allocated internally for which method? Recursive method. Reply again. Execution starts from main method. Calling which method? Recursive method. Whenever we call the recursive method, control automatically goes to the definition or not? Control automatically goes to the definition. Whenever control goes to the definition, automatically memory will be allocated or not? Internally in the heap area. RAM is there, na? RAM. In the RAM, some memory will be allocated. Allocated to whom? Recursive method. Fine. Try to go through the assume here. This is the memory. Yes. No. Here. Here what we have? What's the output we are getting? Start now. Automatically we are able to see the output. The output is the start. Next one. What's the another line? Recursive method. Once again, memory will be allotted. For whom? Recursive method. Fine. Is this function execution completed? No. Function execution not completed. Without completing this function execution, once again, memory will be allotted here. See this one. Here, once again, memory will be allotted here. See this one. Recursive method. Inside the recursive method. Try to see this one. Inside the recursive method, which one? Start. Fine. Is this function execution completed? No. Once again, calling the recursive method. Once again, memory allotted here. Inside this one, what is the output we are getting? Start. Now, like this also, how many times it is executing? Infinite times it is executing. How many times it is executing? Infinite times. Got it or not? Fine. So, because of this infinite time execution, automatically we will get one error. What is that error? Out of memory exception. This is the one possibility. And another possibility is the stack overflow error. Stack of overflow exception. These two exceptions are possible. Yes or not? How many times memory allocated to recursive method? Infinite number of times. What is a recursion? Anyone? A function calling itself. See this one. This is the recursive method. Calling what? Recursive method. Calling what? Recursive method. Calling what? Recursive method. Then this kind of program we can call the recursion. But same recursion with some breakpoints. Don't execute this code. This is not the appropriate code. Same recursion code with some breakpoints we will use with the help of a binary search tree. This recursion code is there. Now, what's the negative of this recursion code? Infinite loop. In this code, I will add some breakpoints. My code should execute only 3 times. My code should execute only 4 times. Add some breakpoints to this code. After adding the breakpoints to this code, we will implement same code in binary search tree algorithm. Got the rough idea? Na? What's the output? What's the exception we are getting? What is the exception we are getting? Out of memory exception or stack overflow exception. Fine. Go ahead, sir. If possible, please draw the diagram. Online team, if possible, draw the diagram. Please note on it.
Actually, the memory is getting allocated in heap, right? So heap will be storing the permanent elements. And why are we getting stack overflow exception?
Because these elements will store in the memory is there in the heap memory. These elements will store in the one by one.
In the form of
Stack. Not only here, if you check the Google also, this error is the common error. If you check the Google also, the error is the common error. Please draw the diagram. Then we will go for the alternative solution for this problem. Guys, once completed, let me know. Who you are watching in the YouTube, who you are watching in the Zoom. Can I add some breakpoints to this execution? Can I convert infinite loop to number of executions? I want to convert this infinite loop to number of iterations, like a number of times we need to execute. Yes. Can I continue? Yes. Same code I need to explain. Try to say this. Same code I will explain you. Try to say this one. Here, call one method. Can you tell method here? Which method? Can you tell the important method? Which method? Public static wide main string array box. Fine. Insert that one. Call one method. Which method you wanted to call? Give one method. Pass some number. I wanted to pass the some number here. Which number you wanted to pass? 3. So my recursion, I want to execute only 3 times, not infinite number of times. My recursion code, I want to execute only 3 times, not a number of times. So that's why we are passing what? 3. Next one here. And one more thing. How to create a M1 method? How to create M1 method? Static void M1. Pass the what? Pass the int x. Now print the x here. How to print x? How to print x? System.out.println of x. System.out.println of x. Now say this one. If x greater than 1, if x greater than 1, call M1 method again here. Call which method? M1 method again here. M1 method here x minus 1. X minus 1. Close which one? If block. Close the if block. Then go to the system.out.println of. Here I need to pass the ExcelR. And close which one? M1 method. Fine. Now can you tell the execution of this code? You people should tell the execution of this code. Which method I am calling? Tell me, which method I am calling? M1 method. I am calling one method, that method we can call the M1 method. Automatically, control goes to the M1 method now. Automatically, control goes to M1 method. Whenever control reaches the M1 method, automatically memory will be allotted or not. Memory will be allotted to M1 method. Am I right or not? So here memory will be allotted. Memory will be allotted to whom? M1. So what is the X value? What is X value? 3. Now print what? Print what? Printing what? I'm printing what? I'm printing 3 or not? I'm printing the 3. Next one. After that, if X greater than 1, reply X greater than 1. Is it true or false? True. 3 greater than 1. True or false? True. If it is a true, once again memory allotted to M1 M1 with what? 2. M1 of what? 2. Now here print what? Print what? I'm printing the 2. I'm printing the 2 here. Next one. And another thing. 2 greater than 1. 2 greater than 1. True or false? True. Once again I'm calling M1 method. Once again I'm calling which method? M1 method. With which value? 1. And print what? And print what? 1. And print the 1 here. Next one. See the another thing here. Now once again, can you tell again here? Now after executing this one, M1 method called here. Are any other thing apart from this one? Tell me. So where we stopped? Can you tell the flow again? Calling which method? M1 method with what? 3. 3. Printing the 3. Go ahead, tell the flow. Printing the 3. Next one. 3 greater than 1. 3 greater than 1. True. Call M1 of 2. True. True in the sense? Again. True in the sense? Again. Which method? M1 method. So finally this method calling how many number of times? 3 times. Once again. Can I call once again 1 greater than 1? 1 greater than 1 false or not? 1 greater than 1 false. At that time, here we got the output here. What is the output we are getting? ExcelR. After completing the execution of this one, immediately the control goes here. Now, here what's the last statement? ExcelR. Now we are getting the last statement here. The last statement is the ExcelR. After completing the execution of this second time, once again it will go to first time. So we are getting what? We are getting the ExcelR. So finally tell the output here. What's the output? 3, 2, 3, 2, 1. 3, 2, 1. Next one. 3, 2, 1. ExcelR, ExcelR, ExcelR. So if I run this code, this is the output we are expecting. Guys, are you understanding the internal execution, internal flow? Are you understanding internal flow? Or do I need to repeat? Yeah, it will repeat. It will go to the backup because the code not executed completely. The code not executed completely. See this one? Three stored here. Printing the output is the 3. Finished. Next one. True. Once again. 2. Here what we have? 2. Here what we have? 2. Print the 2. 2 greater than 1. True. 1. Here we have the 1. Print 1. 1 greater than 1. False. False in the sense print the ExcelR. Okay, now after printing the ExcelR, once again go to his caller. Who is the caller of 1? 2. In the previous call, ExcelR not executed now. Yes or not? So once again, he will go to his caller. Who is the caller? 2. And he will go to his caller. He is the caller. Who is the caller? 3. So this is the one of the technique in the recursion. Okay, now finally, if I run this code, what's the output we are getting? 3, 2, 1, ExcelR, ExcelR, ExcelR. Fine. Now draw this diagram, online team. Okay. Camera. Why should draw the diagram? You people should draw the diagram. Make it fast, guys. Once if we complete, let me know. Then I will tell the algorithm for the recursion, algorithm for the this binary search tree. Give the chance to the other people also, Tarun. Give the chance to the other people. Make it fast, guys. So whoever are taking the notes, so please draw the diagram clearly. Chetan. Yes. No. Let me see the one more program. Same recursion algorithm, same recursive algorithm can I use in the binary search tree? BST. Can I use in the BST? Can I show the some pseudo code? Yes, I will show the some pseudo code how we can implement it with the binary search tree. Let me go for the paint diagram. Assume this one. This is one node. This is one node. And here we have the one more node. Here we have one node, and here also I have the two more nodes. This is the left node and this is the right node. Yes or not? Each node divided into how many partitions? 3 partitions. So this is the partition 1 and this is the partition 2 and the partition 3. Partition 1, partition 2, partition 3. This node also divided into partition 1, next one, partition 2 and partition 3. And this node also divided into partition 1, partition 2 and partition 3. Each node divided into how many partitions? 3 partitions. Now here, tell me here. Here, what's the address of it? 1000. What's the address of it? 2000. What's the address of it? 3000. How many nodes we have? 3 nodes. What's the address of the node 1? 1000. What's the address of the node 2? 2000. What's the address of the node 3? 3000 here. And like this also, we have the tree. Then this structure we can call a binary search tree. Fine. Here, address of left node. Can you tell address of left node? 2000. Can you tell the address of the right node? 3000. Can you tell the data here? What is the data? 10. Can you tell the data here? Data is the 20. Can you tell the data here? Data is the 30. Node 1 contain which data? Node 1 contain which data? 10. 10. Node 2 contain which data? 20. Node 3 contain which data? 30. Left node connected here or not? Am I right or not? Right node also connected here or not? Left node connected here and right node also connected here. Fine. Coming to left node, does it contain any child nodes? Any child nodes? No, but we can place the number of child nodes, not an issue. But here, no child node. That's why we need to go for the null. Here, is it containing any right child node? No. So that's why we need to place null. And another thing, does it contain any left child node? Null. Does it contain any right child node? No, null. Got it or not? At present, for the simplicity, I'm placing the null. But in the reality, we have the number of child nodes. Then that structure we can call a binary search tree. Can I write a recursive algorithm? Let me write the recursive algorithm, just like a previous code only. How we can write the recursive algorithm? Say this one. What's the function name? What is the function name? Recur in order. Now, here we need to pass the address. Some pseudo code. Don't think this is the real code, some pseudo code. What is the method name? What is the method name? In order. The method name is the in order. Here we need to pass what? Address. What is the address? 1000, 2000, 3000, something we have. Address generally we can call the pointer. Address generally we can call what? Pointer. Fine. Inside that one, check this one. Fine. Check whether the node contain left node or not. Is it a node? Am I right or not? Is this node contain left node or not? Check it. How we can check it? How we can check it? If node contain left node or not. If a node contain which node? Left node or not. Like I'm using what? Lambda expressions. Or some, don't put your focus on the arrow symbols and stars. Please put the focus on the recursion only. Fine. If it is contain left node. If it is contain left node, call again here. Call which method? Call which method? In order method. Fine. While calling, what we need to pass? While calling, we need to pass the left node. We need to pass whatever the left node we have. That left node address we need to pass. That left node is address is nothing but the 2000. What is the main method? Can I tell the main method? What is the main method? In order. Fine. Here passing the what? 1000. Is the 1000 contain left? Yes or not? Yes. If it contain, call the method again. Call the method again. A method calling itself only. called as recursion. Called as what? Recursion. After that, print the data. I wanted to print the, after completing this one, we need to print the data. Whatever the data we have, okay, that data we need to print. How we can print the data? How we can print the data? Print data. Print data here. Next one, same process. We need to go to the same process here. If, tell me here, if P contain what? Right node. Call the recursion. How we can call the recursion? How we can call the recursion? In order. In order of what? In order of what? Simply we need to go for P of right. Fine. After calling the P of right, print the data. How we can print the data? Print of P of data. Into P of data here and call the close the method. Whatever the method we have, that method we need to close. Fine. If you are able to understand this logic in a data structure, one algorithm finished, then this algorithm what we call? Binary search tree, BST algorithm. Fine. Explain here. This is which node? Root node. What's the address of this node? What's the address of this node? 1000. This is which node? Left node. This is which node? Right node. Then this node we can call the left node and this node we can call the right node. What's the address of the left node? 2000. What's the address of the right node? 3000. The address is the 2000. The address is the 3000. Got it or not? Fine. Say this one. If left node available, call function itself. Call function itself. Calling function itself, technically what do you call? Recursion. If after calling the function, print what? Data. Now check it whether the right node available or not. If a right node available, call the function itself. Which function? In order P of right and print the data also. Please draw the diagram, guys. Then we will go for the internal flow. Draw the diagram. Guys, if you understand this diagram, you may feel like one algorithm completed in the data structures. Make it fast, guys. Draw the diagram. I'm requesting all the people, online people, please draw the diagram. Sir, 20 we wanted to declare as the root. Which one? Can you tell which one? Yes, the right answer. You are saying like order is not correct, no? Yes, your point is right. Your point is right. Yes, sir. He's saying like the diagram is the wrong. He's saying like don't place the 10 here. Don't place the 10 here. Here, we should place what we need to place. We should place the 20. All lesser elements left side. All higher elements right side. That's a principle. All lesser elements should display in the left side. all highest element displayed on the right side. So,
Ascending order.
no, there's a principle in the binary search tree. Based on the root node, take the root node. From root node onwards, all lesser elements in the left side and all highest element on the right side. So that's why here lesser element. What's the lesser element? 10. What's the biggest element? 30. That's a principle in the binary search tree. What are the diagram I written at the beginning? That is the by mistake we are writing here, but this is the correct diagram. One, guys, tell the internal flow. Can you tell the internal representation? Will you people tell the internal representation? In order of 1000. See this one. In order of 1000. Assume this one. In order of 1000. True or not? True. In order of 1000, this is the true. Fine. Now check it out. Check it out. Is it contain left element or not? Say yes or not. Yes, it contain the left element. If it contain left element, once again go to once in memory allotted to once in memory allotted to whom? In order of what? Left. What's the left? P of left 2000. In order of 2000. Now what is the P here? No. What's the P now? 2000. Is it contain any left? Is it 2000 contain any left? No. False. False in the sense print the data. This line won't execute now. Yes, sir. Print the data. How to print the data? Answer is the 10. Got it or not? Now, guys, whoever feeling like difficulty, see the recursion flow, guys. This is not the great one, just a recursion flow. See the recursion flow, you need to see the recursion flow. Fine. Call which method? Initially call which method? Initially call which method? In order of 1000. True na? True. Now, see this one. Here, check. Is 1000 content left or not? Is 1000 content left? Yes, 1000 content left. True or false? True. If it is a true, call the method again. Call the method again with 2000. P of left means what? 2000. So here I need to call the method again here. Which method? In order of 2000. Guys, what is the P now? 2000. What's the P now? 2000. 2000 left. No, 2000 left. Do we have 2000 left? No. So if code won't execute. 2000 dot data. 2000 dot data. What's the answer? 10. Yes, so this code executed. Good. 2000 write. 2000 write. Do we have any data in the 2000 write? 2000 write, we don't have any data here. Fine. Now, will it call? No. And print of p dot data. Print of p dot data. Answer 10. Answer is the what's the answer? 10. Let's just wait here. Can you explain here? Can you explain this one? Now, try to see the flow again. In order of 1000. 1000. True or false? Is 1000 content left? 1000 content left. So, in order of 2000. This is the 2000 or not? Now, in order of 2000. Now, this is the 2000. Is 2000 content left? No. So, it won't execute. And print the data. Print the data. What is the data? 10. Now, 2000 writer. Is it contain any writer? No, it won't contain the write here. Now, will it execute? Will it execute? No. Guys, here, write data data. Do we have any write data data? P of data. 10 only. P representing the 2000 na? 2000. So answer is the what is the answer? 10 only. But maybe we may remove that data with the actual code. Fine. Now, guys, see this one. And another thing. Okay, fine. I hope no need to try the last print function. Remove this one. Someone saying don't write the last print code. Remove this one. Now, if I remove, now check this one. If I remove, check this one, guys. If I remove, check this one. Now, guys, 1000 left. Is it content left? Yes. Yes, sir. Next. What happened? Focus, and we need some focus, not more than that one. Check this one. In order of what? 1000. Okay, na? Is it contain left? Is 1000 contain left? True. In order of 2000. Now say this one. Here we have what we have? In order of 2000. Now, what is the P here? 2000. Is it 2000 contain left? No. So it won't execute. Will it execute? It won't execute. Now, print to left data. What is the left data? 10. Next one. Is it contain any right? No. So any data, can I call the in order again? No, we can't call the in order again here. Whatever the in order we have, that in order we can't call it here. Okay, na? Next one. And another thing, guys. But coming to what about this 3000? What about this 3000? What about this 3000? We need to call again, na? We need to call again. Let me check the algorithm, proper algorithm. No. I think, wait here. Guys, it's wrong. Wait here. Whenever it's completed, once again, it will go to the previous function, na? Am I right or not? Once again, it will go to the previous function or not? Once again, it will go to the previous function. Stack, na? We forget that one. In the previous example also 3, 2, 1 goes to the back or not? Goes to the reverse back here. Now, here say this one. Is it contain now 1000 na? Now we're in the 1000 na? Is it contain any right? Yes. Is it contain any right? Yes, contain the right. It contain the right here. So is it a true? Yes, it's a true here. If it is a true, what's the P dot data? 3000. P dot data. What's the P dot data? 30. Here we have the 30 here. We're able to print the 30 here. Now, guys, we forget the reversal traversing. Reversal traversing, we are forgetting that one here. So now we got the answer as the 30. Just to do yourself, guys. I'm getting the little bit confusion in this flow. Do yourself. Take the diagram and draw yourself. Yeah. Take the diagram and draw yourself. I got the little bit confusion in this one. That is the recursion. There's a breakpoints I need to place. Then only we can work with the search tree.
Even in the previous example, the ExcelR is printing the other two times.
Exactly.
So why is it again going?
We return the logic like that. In the stack, the logic will be like that.
That is printing due to the
Stack. Guys, I'm requesting all the people take the diagram and draw the diagram yourself. No. Draw the diagram, guys. You people need to draw the diagram. Guys, if anyone draw the correct diagram, can you share that diagram? Guys, if anyone able to finish, draw the correct diagram, guys. Draw the diagram and share the diagram. Do it faster. Anyone able to trace out that code? Chapin, once if you trace out the code, then send the correct information. Anyone, guys, anyone able to finish? I'm waiting, guys. I'm waiting here. Yes, sir. Once if you finish, you save the screenshot. Are you getting the proper output? Sachin, are you getting the proper output? Reply, reply. Yes, backtrack. Because of the backtrack only we will get the output. Yes. Yes, right answer, guys. Only 2 members done. Remaining people. Still anyone drawing? Still anyone drafting that one? I left that one, guys. You people need to do this one. Understand this algorithm and draw with the help of pen and paper. Aman, why you are getting the 10, 20, 30? Because of in order traversal. Because of in order traversal, you are getting the 10, 20, 30. Still anyone trying? Still, I will wait, guys. Still, if anyone trying, I will wait. Otherwise, I have some code. I have some snippet on the binary search. Then I will explain that code. Then you people need to implement it. Yes. Aman, I need the algorithm. I need the algorithm for the post order and pre-order. Yes, 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 yes. Let me explain this flow with a clear-cut manner, guys, so then you can get the clarity here. Let me try. Let me try once. Fine. Guys, what is the P? Everyone, guys, I'm requesting whoever watching in the YouTube and whoever watching you are attending here, I'm requesting you give the confirmation. Give the confirmation, then I need to do. Otherwise, we won't leave it. Fine. Now, if of 1,000. Guys, say this one. If of 1,000, right or wrong? If of 1,000, right or wrong? Right. 1,000 right. Fine. Now, is it contain left element? Is it contain left element? Say yes or no. Yes. If of 2,000, right or not? Right. If it is true, call method again. Call method again. Which method? Call which method? Call in order the method. In order of what? 2,000. Guys, remember here how many lines of code executed? Here how many lines of code executed? Only 2 lines of code executed. Remaining code not executed. Remember that one. Remaining code not executed. Only 2 lines of code executed. You people need to remember this one. Guys, P of 2,000. Guys, say this one. P of in order of 2,000. In order of 2,000 here. Now assume this one. Guys, is it 2,000 content left? Is it 2,000 content left? No. Will it execute? Will it execute? No, no. Guys, what is the print P of data? Print P of data answer. What's the print P of data? Print P of data is the 10. Next one. Guys, is it contain any write? Is it contain any write? No. Is it contain any write? No, no. Guys, will it execute? Will it execute? It won't execute. Guys, but remember this one. Once again, the execution comes here now. Once again, the execution comes here or not? Once again, the execution comes here. Execution not completed, guys. Execution not completed. Guys, what is the P of data? What is the P initially? What is the P initially, guys? What is the P of data? Reply, guys. What is the P of data? 20, 20. Fine, guys, this is the original node. Guys, is it contain right node? Is it content right node? Yes, guys. If of 3000, guys, in order of guys, in order of what? In order of 3000. In order of 3000. Now this is the right flow. Guys, is it containing any left? No. Guys, will it execute or not? It won't execute. Guys, what's the P of data? What's the P of data? The P of data is the 30. The P of data is what? 30. Guys, I missed that backtracking. I missed that backtracking. That's why we are getting the confusion. Yes, so now this is the right flow. Guys, are you okay? Are you okay? Can I explain slowly? Are you okay or can I explain slowly? Instead of if condition, yes, you can take it. You can take it, not an issue. Yes, you can take it. I'm writing the rough code, guys. Don't put more focus on this code. Just a rough code I written. Yes. Yes, sir. Guys, can I show the some ready-made code? Already I have the some ready-made snippet. Can I show that code? Yes. Reply. Can I show that code, guys? Yes. Let me show that ready-made snippet. In the online, we have the some code. Before the session itself, I prepared that code. No. Check this one. Guys, what is address? Guys, what is address? We can call the node or not. Answer, we can call the node or not. Answer, we can call the node. Node internally contain what? Node internally contain what? Data. Node internally contain data here. Node internally contain left address. Node internal contain right address. Guys, we're initializing this node with the constructor. We're initializing that node with what? Constructor. And so we should initialize that node now. We should initialize that node with the left data, left address, right address, and the proper data. Then this one we can call constructor. Now, guys, what is root node initially? Root node initially is the null or not? What is the root node initially? Answer. What is the root node initially? Root node is the initially null. Whatever the root node we have, that root node is the initially null. I'm repeating again here. Guys, now you people need to say this one. Guys, is it a class? Answer. Is it a class? Yes, this is the class. Now, class in the sense you may feel like an address, like 1,000, 2,000, 3,000. You may feel like some address. Fine. This class contain how many variables? 3 variables. What is the first variable? Data variable. What's the second variable? Left variable. What's the third variable? What's the third variable? Right variable. How we need to initialize? We need to initialize with the help of constructor. We should initialize with the help of constructor. Whenever we create a binary search tree, at that time root is what? At that time root is what? At that time root is the null. Whenever we create the binary search tree, at that time root is the null. And another thing, guys, to insert a node, in order to insert a node, I want to create one method. What is that method? Insert method. What is that method? Insert method. For the insert method, we need to pass what? Data. Simply, we should pass the data here. Now, this insert method, calling which method? Calling which method? Calling one method, insert record method. Understand the logic? Insert record method. Here, what we are passing? Root. And what we are passing? Data. Now, the control goes here. Guys, if no root, assume here no root, and whatever the data we passed, then this is the root node or not? If no root, guys, if no root not available, if no root, whatever the data we passed, that data passed to the root element or not? That data passed to the root element. I don't know how many members are capturing. I don't know that one. But to try to say this one, can you please explain again? Here? Explain the flow up to now. Guys, this is what? Guys, this is what? Class. Reply. Not only one or two. Aman, all the people. Shahil, reply. This is what? This is the class. Class is nothing but the address, like 1,000, 2,000, 3,000, something we have, 1,000, 2,000, 3,000, something we have, that is called as the class. Fine. Now, initially take the what? Root node. Initially, we should to take the root node here. Fine. What is a root node initially? Null or not? What is the root node initially? What is the root node we have? That root node initially null. Here, whatever the root node we have, that root node is the initially null. Fine. Next one. After completing that one, try to say the another thing here. We need to call one method. We should call one method. What is that method? Insert method. Insert method here. For the insert method, pass the what? We should pass the data. This insert method, calling which method? This insert method, calling which method? At least one person. This insert method, calling which method? It is calling the insert record method. For the insert record method, are we passing the root and the data? Yes, we are passing the root and the data. Guys, if no root, assume here root not available. If no root, guys, if no root, say this one here. If no root, what do you call? If no root, so whatever the data we have, pass that data to the root node only. Fine. Next one. If root already available, we need to compare it now, like a left node, right node. We need to compare or not? Guys, we need to compare or not? Say this one. If data less than root node, that element you need to populate to left or not? That element you need to add to left or not? Say this one. This code is used to add the node at left side. Guys, else condition. Add the node to the right side now. Add the node to the right side. And return that node now. Fine. Guys, are you people getting a rough idea? Are you people getting the rough idea? Tell me. Rough idea, guys. Or can I get the overview again? At least to tell the point, guys. At least you need to tell. Guys, this is what? This is what? Pointer like 1000, 2000, 3000 K. What is root initially? Null. Guys, to insert the nodes, which function I am creating? Insert function. That insert function internally creating what? Insert record function. Guys, I am not forcing you use the same code. I am not forcing you use the same code here. No need to use the same code. Based on your interest, you can go for some other code also. But logic is important here. You may say, sir, why insert method, insert method, why insert record method? If you don't want to go for the two method, make it as a single method. I'm not insisting you, please go for the same code. You can modify the code also. Insert record here. Now see this one. If no node available, first node is the root node. If node available, if data is less than root node data, link to left side. Am I right or not? If data is greater than node data, link to right side. And after that, we need to return that node. Fine. Guys, this is nothing but the inserting the data. Whatever we have, this logic is used to insert the data. Same recursive method, guys. Whatever we done now, same recursive method here. Next one. Guys, go through the another thing. I wanted to create one method. Guys, I wanted to create one method. Which method I need to create? Search method. We should be in a position. I need to create one method. That method we can call the search method. Guys, we need to pass the data now. We should pass the data or not? Fine. This is search method. Calling which method? That is search method. Calling which method? Search record method na. Whatever the search method we have, that is search method calling the search record method here. Mayur Misra, Surya. Say this one. Whatever we have, it is calling the search record method. Guys, this is the data I wanted to search in this node. Guys, no nodes are available. Guys, no nodes are available. Assume here in the binary search tree, no nodes are available. Return what? False. Return what? False. Return false in the sense, so no nodes are available. Binary search tree is the empty. Fine. For example, another thing, guys. If root to data matches with the data, guys, in the single shot we are performing the searching operation. Return what? Return true. Simply we need to return the true. Guys, if data available in a left, like if data less than the root node data, You need to call the search record method again and again or not. Recursion or not? Recursion. Fine. If data less than the root node data, perform search operation in the left root. Guys, you need to perform the search operation in the left root, like a left tree. Fine. Yeah, say this one. Otherwise, perform the search in, or otherwise perform the search in right tree, right portion of the tree. Next one. Here and another thing is the guys, so these are the common method, like say this one. These are the methods I'm calling here. What are the methods are they? That methods I'm calling here. Guys, can you please run this code into your laptop, guys? Try to run this code into your laptop, then you are able to see the output here. Run the code here. Yes, now we are able to see the output. Guys, 30 available or not? 30 available here. Guys, check this one. I wanted to check. I wanted to search 3,300. Guys, do we have any 3,000? Guys, do we have any 3,000? No, 300 is not present here. Guys, say this one. Copy this code. Then I wanted to share this code to you.
Daddy, ఎవరిచ్చారు ఎవరిచ్చారు ఇదేనా
Guys, let me upload this file to the Google Drive itself. Or let me pin the code here. I wanted to pin the code here. Whatever the code I here, whatever the code I have, that code I needed to pin here. Guys, download from here. And let me share with the Google Drive also. Susmita, upload this file to the Susmita. Please upload this file to the Google Drive itself.
Yeah, sure, sir.
So all the people, I'm requesting all the people, please run this code. Still we have the 3 more days now, guys. Still we have the 3 more days. Like in 3 more days, let me cover the basics of other programs also, dynamic programming, hacker rank, and time complexity, space complexity, and graphs. These 4 things I need to cover in the next 3 days. Guys, I'm uploading that code to the drive. Please download that code and please run that code. Let me know whether the code is executing or not. Guys, are you people able to download the code? Yes. And if possible, can you write the comment in that code also? Write the comments in that code. Guys, YouTube, whoever watching on the YouTube, I'm requesting you download the code and execute the code. Fine. Yeah, guys, but before ending the session, guys, I will ask the some revision questions. So please tell me here. You people need to tell some revision questions. So please do in the chat box. Just 10 to 15 minutes. Guys, question number 1. Collection of indexed elements called as what? Array. Called as array. Yes or not? Guys, index number starts with anyone chat, and index number starts with the 0. Fine. Guys, I will ask one more question. When to choose arrays while developing the application? When to choose arrays? When we should choose the arrays? If we know size initially. When we know the size of array. Very, very important. When we know the size of array. When we know the size of array, at the time, it's recommended to go for the arrays. If we know the size initially, it's recommended to go for the arrays. Yes or not? If we don't know size initially, then at that time, you need to go for the linked list. At that time, we need to go for what? Linked list. Linked list we need to use. Fine. And another point. Try to see the one more simple point. Guys, stack follows which one? Stack follows which one? Stack follows the reply. Stack follows which one? Stack follows the LIFO, last in first out. Stack follows the last in first out. Guys, queue follows first in first out. Coming to the queue, whatever the queue we have, that queue follows the first in first out. Fine. Reply guys. If our operation is insertion in a middle, if our operation is insertion in a middle, one element I wanted to insert in a middle, so choose what? Linked list. We need to choose the linked list. Fine. Tell me here, guys, are linked lists linear or random? Are linked lists linear or random? Linear. Coming to the linked lists are linear. Fine. And linked lists categorized into how many types? 3 types. One is the single linked list. Another thing is the double linked list. Third one is the circular linked list. So the linked list divided into 3 things. One is the single linked list. Another thing is the double linked list. And third one is the can I tell the third one? Third one is the anyone. Third one is the circular linked list here. First one is a single linked list, double linked list, and third linked list. A circular linked list here. In a single linked list, can you answer? In a single linked list, node divided into single linked list node divided into two portions. One is memory. One is the data, one is the data, another thing is the link. Fine. That link contain what? That link contain what? Whose address? That link contain whose address? Next node address. That link contain next node address here. Guys, explain double linked list. Can you explain double linked list? Anyone? Double linked list divided into three portions. One is the previous and another thing is the data. Third one is the next. Third one is what? Third one is the next. Previous contain previous contain previous node link. Next one contain next node link. Fine. Guys, can you please explain circular linked list? Can you please explain circular node circular linked list? Circular linked list. Anyone? Last node connected to at least one person. Last node connected to first node. Whatever the last node we have, that last node connected to the first node, then that one we can call circular linked list here. Fine. After successful completion of that one, then we need to go to the trees. We should go for what? Trees. In that trees also, we are looking for what? We are looking for what? Binary search tree. In that trees also, we should looking into binary search tree. Which one we need to say? Binary search tree here. Fine. Coming to the binary search tree. Fine. Now, lesser values compared to root node. Lesser values compared to root node. Display at the left side. Higher values compared to root node. Display on right side. Got it or not? Display on what? Right side. So, in binary search tree, are we using single linked list or double linked list? In a binary search tree, are we using single linked list or double linked list? We are using the double linked list. Got it or not? Yes, so this one completed. Fine. After completing the binary search tree, guys, can you tell the deletion process also? Can you explain the deletion process? How we can perform the deletion process? Deletion process, we have the three approaches. Fine. Can you tell the first approach? Can I tell the first approach? Leaf node approach. The first approach is the leaf node approach. What is a leaf node approach? What is a leaf node approach? The node won't contain any left child and right child. The node won't contain any left child and right child. So that one we can call the leaf node. Fine. Second approach. Can I tell the second approach? A node contain only one child. A node contain only one child. So that one what do you call? That one what do you call? That one we can call node contain the only one child. Guys, what is the another thing? What is the third approach? Can I tell the third approach? Node contain both the childs, both the left child as well as right child. A node contain both the left child and right child. So that is the process. Got it or not? Fine. See the one more point. Guys, how to delete a node? How to delete a node? If you want to delete the node, first of all, we need to go to target parent or not. No. We need to go to parent or not. Target node related parent. Target node related parent node. Fine. Try to go to target node related parent node here. After going to parent node, you need to make the nullify. Simply you need to press what? Nullify. Guys, and another thing. If it contain one child, guys, if it contain one child, tell me. No, you need to answer. If it contain one child, how you can perform the delete operation? Go to the parent node. From the parent node onwards, search the linking of either left to right. Like a subchild element is there now. We have the subchild element. That a subchild element we need to link to either left or right. And don't forget, guys, that's important. Fine. And another thing, guys, A node contain two childs. A node contain two childs. How we can perform the deletion operation? A node contain two childs. Not all root node. You people are fixed with the root node, not only root node. You are saying root node. No, not only root node. We have the some other approaches also. Tell me. Divide BST into two parts. Left tree and right tree. In the left tree, identify the max element and replace with the root node value. Okay, and another thing. Or can you tell the one more solution? Can you tell the one more solution? The one more solution is the in the right side tree. In the right side tree, identify the min element. Identify the min element and replace with the root node. So that is the solution. Okay, now that's the solution. Okay, fine. Guys, in a BST implementation, in a binary search tree implementation, coming to the binary search tree implementation. So which one we are using? Recursion. Recursion. We are using what? Recursion. Guys, so what is the recursion? A function calling itself. Guys, a question I'm saying, answer as I'm saying. A function calling itself called as recursion. Guys, in a recursion, you need to place some breakpoints or not? In the recursion, you people need to place some breakpoints. Yes or not? Through that breakpoints only, we can break. We can break that infinite loop. Whatever the infinite loop we have, that infinite loop we are able to break it. Otherwise, we can't break the infinite loop. We are unable to break what? We are unable to break the infinite loop. So that one we can call the recursion. Guys, reading. Coming to the reading point of view. How many ways can we read the data? How many ways we can read the data? 3 ways. We are able to read the data in 3 ways. First one, in order traversal. Another thing, pre-order traversal. Third one, post-order traversal. We have the three things. One is the in-order traversal. Another thing is the pre-order traversal. Another thing is the post-order traversal. So we are able to read the data in 3 ways: in order, pre-order, and post-order. Okay, now. Yes. Okay, now. Fine. Yeah, guys, I'm concluding the session today here. Yeah, Susmita, they executed the code here. Susmita, you can conclude the session today because the program executed here. Then you can conclude the
Yeah,
session.
sure, sure.
Guys, so whoever executed the code, then you can drop it.
Student, don't exit. I will share the attendance link. Once you mark your attendance, then only you can exit. Kindly wait, I'm sharing the attendance link.
Sir, we can also make a BST using the iteration. Aman, we can make it. Aman, we can make it, not an issue. But it's recommended to go for this recursion mechanism. Manikanta, tell me, Manikanta. You need the deletion, Harsha. You need the deletion, Harsha. You need the deletion code also, no? Yes, I will tell. Just remind me that tomorrow I will add just a few lines of code. Now here we done what? Only insertion and searching operation. 2 operations we done. But you ask like a deletion, then try yourself, no? Try yourself. If you are unable to let me know. If you are unable to do it, let me know. And tomorrow I will do that one. Add it, Aman. You can add it. I will add all searching order. You can add it like a pre-order and post-order. Him ask again. Someone asking. Manikanta. Tell me, Manikanta. Please teach us C++. Tomorrow, na? Jaishwal. Tomorrow definitely I will go for C++. Manikanta, I will try. Tomorrow, na, guys, we have the 3 days chat and compulsory. Lead code, a few questions I will discuss. hacker rank, a few questions I will discuss. And one more thing, Manikanta, let me know that one. And the time complexity, space complexity, graph. And these people are asking the aviatory. Okay, now I will try it. I will try it. Okay, 3 days still we have the 3 days now. 3 days, let me touch that areas also. I need to touch that areas also. Harsha, you need to prepare a lot. Harsha, I'm giving the path. I'm giving the road opening scale. I'm opening the channel opening to upgrade yourself. Based on this knowledge, you need to implement it. You need to enhance it. Money, yes, we need to implement it. Yes.
I have shared the attendance link. Kindly mark your attendance, guys. Students, even drive link I have sent. If you want any documents, you can download from that. And like some are asking, we can leave the session. If you are done with the attendance, if you mark your attendance, you can drop the session. So some are asking about an test or exam. So on your last day, that will be Friday, it's 6th, you'll be having an exam. It's for 50 minutes, 8 to 8:50 will be the exam. Okay, be prepared for that. Whatever has been taught in the session, the same topics will be there, the same questions will be there on the exam. The test is on Friday. Yes, that will be MCQ. So let me share the attendance link once again. Kindly mark your attendance without any fail. So test timings will be 8 to 8:50. Hope you all marked your attendance. So we'll wind up for the day. We'll all meet again by tomorrow. Thank you all. Good night.